Hello, my name is Davik Monick-Miller, and alongside Thomas Mulder and Peter Lin, we welcome you to our Engineering Systems Lab project. We will be walking you through the work we've completed in 3 labs to prepare us for the final project. This semester, our final lab project is to work with 2 Do robots to select desired letters and to complete a word puzzle. The objective includes both sending and receiving specific letters by color to another team in order to complete a small set of words. We'll be walking you through the labs 1, 2, and 3 and the final lab project before we conclude this video presentation. There are also some timestamps in the video description to skip through. Let's get started. First, Lab 1 introduces us to the Dobot robot software and its functionality. We learn how to set up the robot, collaborate its movements, and use different tools such as the suction cup and the clamper. This was crucial for us to prevent the robot from going out of bounds or getting confused with the task that we asked it to do. For our first task, we picked up a block and placed it on a conveyor belt using a combination of the control panel and motion commands like Move J, Move L, and Jump. We successfully utilized both the suction cup and the clamp for this task. In the second task, we placed 4 blocks on a conveyor belt, connected the Dobot to the I/O sensor, and programmed it to detect and remove each block as it passed the sensor. This repetitive process relied on a flowchart to define parameters and automate the robot's response. As an extra credit challenge, we created a Sisyphus machine, programming the Dobot to endlessly place a block back onto the conveyor belt for continuous motion. Every time the block hit the sensor, the Dobot will take it back a couple inches and the process will flow through for eternity. I will now pass it off to Peter to talk through labs 2 and 3.
In Lab 2, our vision-guided robotic experiment with the Dobot focused on automating the sorting of colored blocks. We use color extraction function, and we isolate the specific color in the RGB space. In our case, we use red. And we also use the image morphology to refine the object by removing noise and blob analysis to detect the centroid. These image coordinates were converted into tools coordinate with a calibration transformation. Afterwards, the robot's movement was controlled through move point and suction control blocks, enabling it to pick up blocks and place it to the designated area. The program ran continuously to sort multiple blocks efficiently. The video demonstrates this workflow showcasing the integration of image processing and robotic of precision automation. For Lab 2 Task 1, this video shows that the camera is able to recognize the red block in the view. For Lab 2 Task 2, this video shows the camera is able to see the change happening in its view. For Lab 2 Task 3, we're able to use the robot to move only the specific color on the view, in this case, just the red block. In the first part of Lab 3, we demonstrate robot-to-robot communication through a handshake process. Dobot was programmed to pick out a block from its side and place it in an intermediate location. Once a block was placed, Dobot 1 sent a signal through a circuit to Dobot 2. Once Dobot 2 detects the signal, it picks up the block from the intermediate location and moves it to its designated spot on the other side of the table. The process successfully showcased the coordination between the 2 robots using the simple communication protocol with visual feedback provided by an LED. In the second part of the lab, we automated the identification and placement of rectangles into designated slots using visual guided robotics. The camera captured image of the workspace and the system detect the rectangle using feature matching. The robot adjusts the orientation of each rectangle to ensure proper alignment and use its calibrated coordinate to move the rectangle into their corresponding slots. This text highlights the integration of visual processing and robot precision to achieve accurate and efficient sorting. For Lab 3 Task 1, we had the robot talk to each other to send and receive a blue block. For Lab 3 Task 2, we had the robot to match and rotate the rectangular block to a slot on the view. I will now pass it off to Thomas to talk about the final project.
For the first task of moving the letters to the other robot, first we move our robot out of the way so the camera can get a clear picture of the letters. Then we sort for only the color of letters that we want to see. Then we use the fast match to find our first letter. And once it's found, we use a calibrate transform to find its actual location and then move the robot to that location. The letter is then picked up and then moved to a predetermined location. This is then repeated for the two other letters in a series, so it is not a loop. At the end of this string, we then output a signal to the other robot to let it know that it is ready to do its part. When we were on the receiving end, we had to use a loop and constantly look for the output function to see the signal. Once it found the signal, it would then also move the camera out of the way and take a picture. Then fast match for the letter, and then find its actual location, move the robot to that location, pick it up, wait a second to then make sure it has time to find where it is supposed to go, and then once it has found that, then does the angle calculation to place it correctly. And then it drops it slightly above so that it has ample room to fall into place. This is our robot sending the letters C, A, R, and the signal to the other team. This is our robot receiving the letters B, U, S, and fitting them within 45 degrees of our puzzle. I will now pass off to Divik to continue our video journal.
In this lab, we had a great experience with the Dobot robots, learning not only how to operate them, but also how to troubleshoot them when things didn't go as planned. While we encountered some software bugs that required resets, these challenges helped us develop a deeper understanding of the system and improve our problem-solving skills. It was rewarding to see the robot perform tasks as we intended, reinforcing how important precision and careful handling are in robotics. This lab also gave us valuable insight into the complexities of automation, especially in relation to robots used in the industry, like the FANUC. Working with these robots underscored the level of detail and patience required to ensure smooth operations in an automated environment. The experience has been an eye-opener into the challenges and intricacies of the automation field. We're thankful for the opportunity to work hands-on with these systems and for the knowledge and skills we've gained throughout this lab. This experience will undoubtedly serve as a strong foundation as we continue building our engineering careers. Thank you for your time, guidance, and support through this extremely important learning process. We truly appreciate it.